Okay. Adarsh, Adarsh. Okay. Okay. Deepthi. Okay. Adarsh. Ask them
Sir,
to join the remaining
Sir.
immediately.
yeah, sir, I have put the message in the group.
Okay. Okay. Right. Right. Thank you. All right. Yeah. Let's start that. So, in the last class, we discussed about the uh, mineralogy, what are the minerals, different types of minerals, what occurrence of minerals, physical properties of minerals, how to identify the minerals with the different the properties of physical properties of minerals. Okay, so in that case, so here we discussed in the last class, I think almost all group of minerals here. Okay, so these are the properties which we have discussed, the mineral properties, physical properties of minerals, right? So, uh, same thing for the petrology, which we are going to discuss now. That's model two. Before that, I want to recap what we discussed in the first model. That is what it's the internal structures of the Earth. That's the most important point for your examination point of view, and to understand what is happening in the subsurface of the Earth, and it's a composition, internal structures and composition of the Earth, and where the the what you call the engineering geology, the main applications of engineering geology in the civil engineering practice. Okay, and what is the minerals? Okay, it's exactly it's natural occurring substances, and that are characterized by the different chemical composition and internal atomic structures, right? And yeah, and we discuss about all these properties, how we are going to identify the minerals with the different properties. So say for example, color, streak, habit, the luster, cleavage, fracture, affinity, hardness, specific gravity, chemical composition, occurrence, industrial and economic uses, and magnetic attractions, and react with a diluted HCl. Last two are with the special characters, which some typical minerals which have the each one of that. And the quartz group we discussed that, and this is completely industry oriented, and which use it for our manufacturing for the glasses, and also for ultrasonic equipments and radio frequencies, right? And yeah, this is how it occurs in the field, right? And yeah, in this feldspar group, it's mainly it's used for the porcelain and sorry, the sanitary wares and the tiles manufacturing industries, right? And mica, generally we use it for electrical industries due to high heat resistance property which is having in the micas, right? And yeah, and amphibolite group, it is an hornblende, and especially in the asbestos and hornblende. Asbestos generally we use it for some insulins, and also for the lubricants and paint industries. Okay, and hornblende, it's generally used for manufacturing of the cement, right? So just I'm recapping the previous the classes completely, and this is a typical properties of hornblende, and the uses. And we discussed about carbonate group of minerals, that's calcite and dolomite and magnesite, and all three minerals generally we use it for the manufacturing of cements, and also for some are for magnesite for refractory bricks for furnace lining, and also for electrical elements, right? And yeah, this is about the what it's in the that's called limestone mines, and this is called dolomite, calcite, and magnesite. And also there is a called oxide group of minerals. It's called hematite, magnetite, bauxite, and corundum. And these minerals are used for extraction of iron and steels. For the iron ore mines, really it's hematite and magnetite. So all these minerals, and we discuss about that. Okay. And see, for this, I'm going to share you the notes in the what we call in the Google Classrooms, and you can go through the things, right? And this PPT also I'm going to show there, right? So let's go to the the part of what we call this petrology. Okay. So what is there in the petrology, and what are the things what we call this? Yeah. So mineralogy part, we have seen that. Do you have any difficulties to understand the first model that's called petrology? Hello? Any difficulties? No, I think, right? All right. So let's go with the thing. I think we have finished that, and let me check with the updated mass scale of hardness. Yeah. Almost all we covered the bauxite, chalcopyrite, yeah, iron ore and mica and kaolin. Yes, carbonate and gypsum, right? So now let's go with petrology. It's a study of rocks. It's a branch of geology, which deals with study of rocks. Okay. So then, what is a rock? That's most important. Okay. My voice is audible, huh? Adikeshu, Chiranjeevi, voice is
Yes,
audible, huh? Okay.
yes, sir.
Uh,
Yes, sir.
then what is a petrology? Petrology is nothing but it's a study of rocks. So then in that case, what is a rock? Rock is nothing but it's the aggregate of minerals. That means aggregate of more than one mineral, or it may be a single mineral also. If it contains rock contains a single mineral, that's called a monomineralic rock. If the rock contains more than one mineral, more than two minerals, more than one minerals, that's called a polymineralic. Sorry, the mineralic rocks. Okay, monomineralic and polymineralic. There are two types of rocks, varieties of rocks. Okay, so how the no what is the the basic definition of rocks is, again, it is an aggregate of minerals. So minerals are creating together and made up of the rocks. Okay, and it's a branch of the geology. eh? Right. So here is you can see this some of the the slide is visible. Yeah, slide is visible.
Yes,
Okay,
sir.
so here is the it's how the the mode of formations, composition, and uses of all all types of engineering works for this. Especially the igneous rocks is formed through the cooling and solidification of magmas. Okay, the first formed rock is the igneous rocks. When the volcanic eruption is happening there, that during that time the first formed rock is called a igneous rocks. So that is why we call it as a rock is formed, especially igneous rock is formed during the cooling and solidification of magma or lava. Okay, and the igneous rocks generally with or without crystallization, either below the the surface. If it is below the surface, as we call it as intrusive rocks. If it is above the surface, it is called a volcanic. That's called a extrusive rocks, right? Right. So definitions: natural occurring aggregates of minerals contains the composure of the grains only one mineral. We call it as a monomineralic. The best example is that marble is composed of calcite, and sandstone composed of quartz, and dunite rock composed of olivine mineral. Right. So here rocks composed more than composed two or more minerals called polymineralic rocks. Right. The best example is the granite. What you have seen, most of the people, most of you all seen the granite. Maybe you have used it as a building materials in your house, maybe a flooring, maybe anyway. So it composed of quartz mineral will be there, orthoclase, plagioclase, biotite mica. Yes, you will get all these minerals in granite. The white it generally it occurs, say for example, in the granite, if it contains the white, that is called your quartz, and orthoclase is little bit shining and with the flat like a surface, okay, neat like that, and plagioclase is also same thing, and biotite when it comes to the the black like a sheet-like structures with a black color, that's called a biotite mica. Of course, it's very difficult to identify those things in the polished the granite because with a microscope you can easily identify. But if it is a mega grain, I mean it's coarse grained, the granite is there. Definitely you can identify easily with your naked eye, right? So the basalt is composed of plagioclase and agate, right? So these are the the definitions. What is petrology? What is a rock? And what's a monomineralic rock? What is a polymineralic rocks? With an examples. Okay, right. So let's go to the next slide. That's called the oceanic crisis. That means, so here what happens actually, right? When you see this, you can easily understand how the the magma is erupting, how which way it's erupting, what is the mode of transportation of lava into the surface of the earth. This is completely surface of the earth. Okay, right. And yeah, here is the mantle part. As we discuss in the first model, internal structures of the earth. So here is the mantle part. Cooling magma chamber, and here is down below, that's a mantle part. So mantle part is 2900 kilometer down below the earth from the surface. If we take it, it's a 2900 kilometer. But this is after 30 to 40 kilometer. So after 40 kilometer down below up to 2900 kilometer, that's a mantle part. So it is the lava is erupting from this mantle chambers. Okay, crystal much, these are the crystals parts, and this is a gabbro, and here is the dike. Dike is an intrusive rock. Gabbro is also an intrusive rock, but it's all igneous rocks. Okay, and the basalts. So the top one is the basalts. Okay, this is magma eruptions, right? And this we call it as transitional zones. We call it as a transitional zones. The crystal mesh, uh, the volcanic, it contains the volatile materials. Huge of volatile materials it is having. It contains the minerals. It contains what you call this, gases. Along with that, gases. First, the gas will erupt in the surface of the earth, and then it will start the liquid part. Okay, this is how the hot molten magma is erupting and solidified and consolidations. This is how the igneous rocks will be formed. Okay, so really it is happening in the subsurface of the earth like this. But in India, we don't have the volcanic eruption place. But earlier it was happened, and there are some places in India itself. The volcanic, the rocks you can see on the surface of the earth. But that volcanic, the rocks which is exposed on the surface of the earth, that's so typical one, the shape wise and the strength wise. Shape is totally, very smooth surface on the top, and also it is a well rounded, okay, and that is too hard. It's just like, when you hit with a hammer, it's just like a metal sound. Such a hard one, okay, high hardness that is. Okay, but you may not, it's very difficult to identify for you guys because we are not yet studied that and not yet involved in the what type of rocks and all those things, but it's very difficult. But you can, with this few the words or the ideas, you can easily come out with that. Yes, this is maybe the granite, or it may be the igneous rocks, or it may be the sediment rocks. Easily you can identify. That is not a much difficulties there. Right. So this is a magma chambers. This is a mantle part. Okay. Send the middle part of internal structures of the earth, and this is a gabbro here, and dikes and basalts. Okay. And this is completely the oceanic crust. That's completely the oceanic crust is there. Okay. And here you might have seen this hill. Okay, and surrounding the Bangalore, it is many more many what you call this the rocky structures, rock structures. You can see that. That's called the granite exposed. Bangalore and surrounding Bangalore, even Nandi Hills, Tumkur. From Bangalore to Tumkur, if you travel, you can see on either side of the road, both sides you can see the the granite, the exposures. Huh? Right. And in nearby, the airport, we call it as the Nandi Hills. You can see the, from Yelahanka itself, you can start the, outskirting, and you can see the, what we call this granite exposures on the surface of the earth. Granite, almost all the igneous rocks you can see there. Okay. Not only granite, you can see the, dolerite, granite, cyanite, almost all the igneous rocks, except basalt. Okay. Right. And yeah, so this is a one and exposures. I would say it is yeah. This is the where the granite actually what you call this. This is a granite quarry done in the surrounding areas. See, this is completely excavated. The drill it, blast it, and use it for maybe the aggregates, or it may be slabs, or it may be some other purpose like railway blast. Okay, or it may be use it for as a building stones. Okay, right. So this is a one thing, and this is another one. So here is the classification of rocks. So generally, the rocks are classified into broad classification. That's called igneous rocks, sedimentary, and metamorphic rocks. As we discuss, igneous rocks are formed the first formed rock, which is the solidification and cooling of magma. Okay, and the magma, it contains volatile materials, okay, along with the gases, right? So then sedimentary rocks, then metamorphic rocks. So let's go one by one, and we can complete the things, right? As we discussed, this is the igneous rocks formed by the cooling and solidification of magma or lavas, and at very high temperature, it's generally and at a very great depth, the igneous rocks are formed. And igneous rocks are formed due to, upon the Earth surface, as known as extrusive and intrusive. We discussed there. So further, igneous rocks are further classified by different scientists by different bases. So the supporting documents may be the varies, okay, but on the basis of mode of solidification of magmas, there are many research. I mean, many the scientists working on the different working on different sectors, right? And yes, it's a continuous process. Research and development is a continuous process, okay. Based on solidification of magmas, the scientists, geoscientists, they have described that yes, the igneous rocks further you can classify it with the plutonic rocks, hypobasal rock, and volcanic rocks. So what do you mean by there are many classifications? No, don't get confused in that. So classification of rocks, one is igneous, second one is sedimentary, third one is metamorphic rocks. That's it. So now let's go with the igneous rocks. So in the igneous rocks, it's a first formed rock, right, from the lava eruptions, and it is formed with a cooling and solidification of magma on lava. That's a very simple definitions. Don't get a lot of terms for that, right? And here, based on the the solidification of magma during the volcanic eruptions, so these rocks, especially only igneous rocks, we have classified plutonic rocks, hypobasal rocks, and volcanic rocks, right? And what are the bases? See, these are all the the exposure on the surface in the river itself. You might have seen this. Most of the rivers have the the granite wherever the surrounding areas in the Bangalore and Tumkur, Kolar, and even Dodbalapur, Chikbalapur. Uh, if you go for survey camp, especially in the Melkote, you can see this, and even in nearby Gati, Gati Subramanya, you can see this. Okay, almost all. Maybe highly weathered rock also you can see that, or it may be the what you call intrusives also you can see that. Right. This is how the granitic the things are there, right? And this is called actually the basalt, the coastals. Yeah. The volcanic rocks, you can see this. This is how it looks like this. The block color, well rounded, okay. And when you hit with the hammer, this rock, and it gives us the metallic sounds. So too high digital sound it will come there, okay. And yeah. So here, what you call in the igneous rocks, plutonic, hypobasal, and volcanic rocks. So in the plutonic rocks, and these rocks are which are formed beneath the surface of the earth crust after solidification of magma, and also it cools very slowly and formed the very coarse grind, very coarsely crystallized rocks. Okay. In the plutonic rocks, it forms in the beneath, very deeper level in the subsurface of the earth, maybe more than 30 kilometers down below that, right? And then it cools very slowly because it is not exposed to the air. That's why it is not there is no sudden cooling is not happening here. So because of high temperature and pressure in down below the earth, this plutonic rocks are cools very slowly, and then the rocks crystals are very coarse grind. You can see that. So in the second one, hypobasal rocks. So hypobasal rocks are those rocks which are formed below the earth surface at a short distance. That means maybe the 1 kilometer or 2 kilometer down below that. So hyperbasal rock. These rocks are formed just down below the earth. That's called a very shallow depth. Okay, this happens when the magma solidifies. So when the lava erupting, magma is going to solidifies in the form of thin sheets or wall like a structure. Okay, and generally, usually these rocks are fine grained. It's not a coarse grain. It is not a sorry, the fine grain. It's a very medium grain because it's near to the surface. That's the one thing, and there is no much of high pressure and temperature as we see in the plutonic rocks. Plutonics also formed in the deeper level. That's why it's a high temperature and pressure. But hyperbasal rocks are very shallow depth and near to the earth surface, right? That's why it is there is no that much of high pressure and temperature. The grain sizes are very medium size here. Okay, and volcanic rocks are so here, the volcanic rocks are those which are formed on the surface of the earth, and generally when the magma is forced out of the surface of the earth, okay, due to a sudden change of pressure and temperature, and it rapidly cools. See here, due to a sudden change of pressure and temperature, when it is exposed to the surface, there will be a sudden changes in the temperature and pressure on the ground. So rapidly it start cooling, and that's why it is fine grained rocks will form. Okay, that's a volcanic, and this is how the dikes will form this. Now the black color is the dike, and surrounding that, this may be the highly weathered granite. And the dike is it across almost all the rock formations. Okay, how it's going to across? There are two types of the intrusions will happen. One is dolerite, another one is a sill. So sill is nothing but it is along the formation. How? What do you mean by formation? Say for example. This is a continuous, the different types of formations. Like if you have seen this, especially, I would suggest that it may not be there properly. Not sure it is. Yeah, field photos. Yeah, yeah. Here you can see this. So this is iron ore, the reef in the sense top of the hill. Here you can see this. This is a strike length. This is a strike of this ore body here. Okay. Just I'm going to explain how the dikes will form. Okay, and this is actually the strike line, and this will dipping towards this side. This side in the sense that maybe the northeast side. Actually, it's the northeast side. So east is here and north is here. So northeast side. So here, this is actually the strike directions. You see the alignment here, and dipping towards northeast side. Okay, so here, if there is any igneous intrusions or happen, especially the dolerite dike, and it will cut across this all the lithology or the all the formations, rock formations. It will cut it, and it will start depositing themselves there. So, if it is a sill is another igneous intrusions. Generally, it deposits all along the strike length of the formations. Like one of the formation, it will also there, but it is very difficult to identify. But when it comes to the dolerite dike, it cut across almost all these formations across the strike. It will follow that. That is a thing. This is how the things, right? So generally, this will, it will be like this east-west strike direction, and across this, this dolerite dike is formed. Okay, and yeah. Here is, the another very good the rock exposures. See here, you can see this, right? This is completely, what you call this, pillar. You can see this completely granites. So this type of exposures you can see in surrounding Bangalore districts, even in Bangalore also. But because of organizations, you can't see much of this actually. Okay, wherever you dig the, for borewell, definitely you will get the granite here down below. Okay, right. Yeah, here you can see this complete how it looks. This. See, this is an igneous intrusions that's called your dike. See here, it cut almost all these rock formations like this, right? This we call it as a dike. Yeah, we are having here, okay, volcanic rocks, hyperpressure and igneous rocks. Of course, so there will be one or two questions on this, especially in the first topic here. And what is the classification rocks? What type of what is the basis on this classification will be happening there? Okay, types of the plutonic rocks, volcanic and uh, hypervessel rocks are forming there. All right, and yeah, right. So now, so index properties of rock. What do you mean by index properties of rocks? Right. So here there are the following important, very important the petrographic characteristics properties which are helpful to identify and classify the rocks, especially in the hand specimens. Okay, hand specimens. Okay, by a naked eye, with the aid of some hand lens, and also with the some testing like tools like pen knife, magnetic pen, streak plate, and diluted hydrochloric acids. That's for your carbonate group of minerals. What we are seeing that. Okay. Right. So here is the index properties. What are those index properties? So you studied for these properties for minerals, study of minerals. Some of the properties will be there. For the rocks, there will be a little bit different than the properties of minerals. So in the rocks, so in the minerals, yes, in the color, yes, in that form or habit, and also with the luster, streak, affinity, okay, all those things we have seen. But in rocks, color, okay, and it will be a textures. So like textures in the sense, if you see the any rock, there will be a grains distribution will be there. You can see the sediments. You can see the grains distribution in the rock. So whether it is equigranular, whether it is what you call this unevenly granular distributions, those things you can see this. Okay, and grain sizes in the rock especially, some rocks showing the coarse grain, some are showing the medium grain, some are showing the fine grained rocks. Depends on the area or maybe the temperature and high pressure. These the grain sizes will be varying, right? And the next one is the mineralogical composition. What is there in the mineralogical composition? What are the minerals in the rocks? In the definition itself, we discussed that it is a maybe the monomineralic or it may be the polymineralic rocks. So, in the monomineralic rocks, there will be only one minerals. If there is a polymineralic rocks, of course, most of the rocks are with a polymineralic, right? So what are the minerals occur? What are the minerals are there in each of the rocks that we need to study? But again, in the mineralogical composition, again further we classified there just what is the essential mineral and accessory minerals. Essential minerals, okay, these minerals are the major part of the area covered in the rock. So accessory minerals are minor minerals, it may be there, may not be there in the rocks, okay, that is a possibility. And those things you can easily identify if you have the hand specimen of the rocks. So after completion of this, the what you call this slides, I'm going to show you the how the rocks is going to looks, and how we are going to study this, how we are going to identify the rocks, okay, with the help of these properties, right? Then the cementing materials. Generally, the cementing materials, we used to take it in the sedimentary rocks, not in igneous rocks. Why? Because when you are going to study the sedimentary rocks, first you need to understand what is a sediment. Sediments in the sense it may be a grains, or it may be fine grain size, or it may be what you call medium or coarse one. These are completely sedimentary rocks. Sedimentary rocks is nothing but its a definition is the weathering, transportation, and depositions of the grains, and at the same time it will start the what you call the compaction and cementation together with the oxide group, they're called clay minerals, right? So that I will show you the picture, I mean the photos, field photos, so that you can easily understand the what is the cementing material. Cementing material is nothing but the grains are medium grain, coarse grain, or maybe the fine grains materials getting together, deposited at a particular place, and they are going to associate it and mix with the water as well as clay minerals, getting very harder or compacted. That's called as cementing materials. And what is the specific gravity? As we discussed there for the minerals, the specific gravity will be the medium, low, and high, based on the the composition, internal the based on the the mineralogical composition, the specific gravity may be varying there. And what is the special the properties? Uh, Most of the minerals are have the typical properties, but some properties are common for almost all the mineral, the rocks. It depends, okay. And the acid reactions will be there, and magnetism will be there, attract to the magnet. Okay. So in the color of rocks depends on the color of their aggregate of minerals. What the majority of the minerals inside the the rock, the color will reflect there. Like a face is the index of mind. So if you see the face, you can easily understand what's going on in their mind. Right? Like this, if you see the color, what what kind of, what are the minerals it could be there in the inside the the rocks, that's called face is the index of mind, right? This is how we can uh, remember the things, how we are going to study the physical properties of rocks and minerals, okay. And aggregated minerals and or cementing materials, and is generalized according to the overall shades, okay. And the texture is the defined with a mutual relationship of uh, uh, and actually constituent of mineral grains, mutual relationship of the mineral grains, their size, shape, and etc. Right? Sizes it varies, medium, high, and fine grains like that, and shape will be the different shapes also will be there. Okay, and what is the grain sizes? Grain size is the diameter of component of mineral grains that we know, right? And this how we are going to express as a fine grain. Grain diameter is generally, if it is happening 1 to less than that, that we call it as a fine grain. So if the grain size is 1 to 5 that we call it as an less, or that we call it as medium grain size, right? So so if the grain size is 5 meter and above, sorry, 5 mm, 5 millimeter and above, that we call it as an coarse grain, right? This is how we are going to study the physical properties of rocks with the help of textures, grain size, color, and other properties. Okay, general composition. The mineralogical composition will be the combination of proportion of component minerals. Say, for example, I told you that essential mineral and accessory minerals. What is there in the essential minerals? Generally, essential minerals are easily identified by naked eye. That you need to understand first. And the accessory minerals, the finer particles, finer, very finer, and percentage is also very, very less. And that's very difficult to identify, without, the magnifying lens. Okay. And the grain size, this is the diameter of the component of minerals and expressed as follows: fine, grain, medium, and all those things that we discussed there. Okay. So here, the igneous rocks are further we classified based on the silica percentage of a particular rock. Right. So the classification of igneous rocks. These things we will discuss in the next class, and let's stop this. And you can start reading for the first model, complete model. Okay. And the remaining classification of igneous rocks based on the what you call this silica percentage in the rocks, we can discuss in the next class, right? Yeah. Okay. All right. We'll have the small quiz sessions here for 2 minutes, and okay, anybody can answer what is the how the igneous rocks is forming. Igneous rocks. Anybody can answer this. Darshini,
Slow cool down of lava.
cooling and solidification of the magmas. Okay, what are the types of rocks?
Igneous metamorphic.
And sedimentary, right? Igneous, sedimentary, and metamorphic rocks. How the sedimentary rocks are forming?
Sedimentation
Yeah, sedimentation, correct. That's right. And there
and
is a
weathering.
process called
Weathering.
weathering, transportation,
Weathering,
and
weathering.
deposition in the lowland areas. And then finally, sedimentation will happen along with the what is called compactions, and that is associated with the clay minerals. Right, that is the ones. Could you give, anybody can give the the example of igneous rocks? What are the
Granite.
yes, yes, correct. That's right. And next, granite, basalt.
Basalt.
Yeah, granite, basalt, and those two rocks only you have seen there. Okay, that you can easily identify. And right, granite, basalt, diorite, dolerite. Yeah, you can say those things. And yeah, and what we discussed there in the so forth, so that you can easily understand the things. Okay, what are the physical properties of rocks? What are the physical properties of rocks?
They reject, sir.
Color,
Yeah, color. Yeah. Next,
Texture.
magnetism, mineral composition.
magnetism. Little bit difficult there because it's associated with the it's aggregate of minerals. So it may not be there. If it is there, magnetite. Yeah, of course, there's a possibility there. Yes. Then next.
Texture.
Mineral
Text,
composition.
mineralogical composition, textures. This, mineralogical composition will
Color.
not be there in the, physical properties of minerals. And cementing material also will not be there in the, physical properties of minerals, right? And here in rocks, physical properties of rocks, there will not be any the streak, right? Because it gives the false color, right? Gives the false reading of the streak, right? So because it contains so many minerals, right? So this is how the things. What is the date today? 16, and before that, when we did this? 14. Yeah. So Adarsh, Adikeshu.
Yes, sir.
Sir, others present, sir.
Yes, 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 yes. I can see you.
Adikeshav present, sir.
Adikeshav, Bharat Singh.
Present, sir.
Bharat Singh present, huh? Chiranjeevi,
Present, sir.
Darshini.
Yes, sir.
Oh, slow. Right.